Hey there. So let's look at number 1 on the study guide. And so remember, if you need silence, go down into the answers breakout room. All right, so number 1 says the coordinates of triangle ABC are shown on the coordinate plane below. Triangle ABC is dilated from the origin by a scale factor r equals 2. We have two parts to this question. Part A says identify the coordinates of the dilated triangle A prime, B prime, C prime. And then part B says, is triangle A prime, B prime, C prime similar to triangle ABC, and explain. Okay, so let's see. Okay. So let's go through these two parts. So the coordinates of the dilated triangle. So here we can see the location of A, then B, then C. And so we want to dilate it using the origin as the center. So we didn't do a lot of dilations in the coordinate plane, but we did talk about how dilations in the coordinate plane are much easier than dilations in just the plane, because when the center of dilation is the origin, because there is a trick. Do you remember what the trick is? Does anyone remember what the trick is for dilating using the origin as the center in the coordinate plane? Go ahead. Were you going to hop on the mic?
I forgot to raise my hand, so I was going to do that. But if you dilate using the origin, you can times it by what the scale factor is, and just use the coordinate points for that.
Perfect. That is it exactly. Anytime you have a dilation in the coordinate plane with the origin as the center, all you do is take the scale factor and multiply it by the x value, and the scale factor, multiply it by the y value. That gives you each new coordinate point. Okay, so let's do that for each of the coordinate points. So if we first have A, what are the coordinates for point A? Feel free to share in the chat, Mike. Oh, and then the origin, apologies, if we need to clarify that, remember it's just the center of your coordinate plane. It's at 0, 0, where the two axes meet. Where the x and y axis meet is the origin with the coordinates 0, 0. Good. And so then the location of A is not quite at 2, 2. 2, 2 is, let's see, there, right? It's kind of small, but hopefully you can see it better on yours. That is 2, 2. So it's actually 1 further out. So it is 3 to the right and 2 up. So the location for A is 3, 2. Yes? That's all right. Now let's find the location of B. What's the location of B? And B is kind of small, but it's down here. Whoa. I don't know what happened there. Is everything okay over there, Ashley? All right, what are the coordinates for point B? Who in here knows? Coordinates for point B, as in boy. Oh, Nevaeh, there's 2 of you. I'm removing the other one. What are the coordinates for B? Nobody knows the coordinates for B. Nobody knows what they are. Okay, you go nowhere left or right, and then you go down 1. 0, -1. Is that okay? Yes? No problems? You got it? All right, lastly, what are the coordinates for point C? These are just the original. I'm just pulling them off the graph. Where is that located? Where is point C located? I see some more chat boxes going. The singing helps you. You laugh at Miss Wooten because you feel bad and you feel awkward. Yes. It's actually, Dalen, you're off by like a scale factor of 2 because that means you worked ahead, which is good. So hold on to those numbers, Dalen. So Nevaeh has the ones, I want a current location of C. Then we will apply the rule, okay? So this is the rule, Rx, Ry. So the rule that we are applying, we are going to be multiplying each of those by 2. So 2 times 3 and 2 times 2. Which I will not be writing them that way. Those little dots are going to get messy. We're just going to have lots of parentheses. So the new coordinate point for A prime is going to be what? What's the new coordinate point for A prime going to be? Good. 6, 4. Then we do the same process for B. It's 2 times 0 and 2 times -1. And what do we get out for B prime? 0, -2. Very good. Then the last one for C is what Dalen provided for us correctly earlier. It will be -6, +2. So very good job, Dalen. So that's the answer for part A. Those are the coordinates of the dilated triangle. And if you want to see it on the coordinate plane, you can even take the time to draw that. Right there is A prime. B prime is at 0, -2, and then C prime is at -6, +2. Oops, I don't even know what I was trying to write. There. All right, and then we can use our line tool to connect them. How beautiful is that dilation of a scale factor of 2? It's just the cutest. Okay, so that's part A. Is that okay? Is everybody okay with part A that is here and tuning in? Just give me a green check if you're good with part A. Red X if anything about part A is unclear for you. That's what all this is over here. Green check if you're good with part A. Red X if something is unclear. All right, I don't see any X's. So the part B says, are they similar? If so, and then explain your response. So are those two triangles similar? How do you know if they are or are not? Okay, so remember the way we know if two figures are similar, There's a couple of ways to know. If there is a similarity transformation that maps one to the other, that guarantees there is similarity. Because we performed a dilation, and a dilation is one of our similarity transformations, that means the two triangles are in fact similar. So the answer is yes, because a dilation was performed. And remember that in a dilation, and then we can put in parentheses that this is, and I'm writing it very, short and snippy. You'll want to have nicer sentences than that. So dilation is a similarity transformation. And then in a dilation, the side lengths are proportional. And the angles are preserved. Ashley, did you have a question? Oops. Gotcha. Okay, all right. How's everybody doing with part B? Green check if part B is okay. Red X if something's unclear. All right, I don't see any X's thus far. So I will let you get back to it.